Welcome to Get Your FRQ On. This question is from 1999. It's question 1C. It is calculator active. In the question stem, we are given that a particle is moving along the y-axis, and we're given a function that describes the particle's velocity. In part A of the question, we are asked in which direction the particle is moving at t equals 1.5 and to provide an explanation for why. Since the particle is moving along the y-axis, the answer to this question will be either up or down, not left or right. Left or right is for the x-axis. So whatever the direction is, whatever the particle is doing at t equals 1.5, it's either going to be up or down, and we'll determine that based on the velocity of the particle at t equals 1.5. If the velocity at 1.5 is greater than 0, that indicates that the particle is moving up. If the velocity at 1.5 is less than 0, that indicates that the particle is moving down. Since this is a calculator active question, we can do the calculations using our calculator to evaluate v of 1.5. v of t is given to us in the question stem, so really we just have to indicate that we want to find v of 1.5. Which is 1.5 times the sine of 1.5 squared, which, if we use our calculators, gets us 1.167. All right, so since v of 1.5 is positive, that indicates that the particle is moving up. In question part B, we are asked to find the acceleration at t equals 1.5. and to determine if v of t is increasing at t equals 1.5 with an explanation. So first, let a of t be v prime of t. You may have to declare that, otherwise what is a of t? So I think you have to define ahead of time that a of t is v prime of t if you're going to use v prime to determine a of 1.5. We could find a of t simply by using the product and chain rule on v of t. It's not that difficult of an application. It's not a complicated function. A of t would be v prime of t, which if you use the appropriate differentiation rules, you get 2t squared times the cosine of t squared plus sine of t squared. And since it is a calculator active question, we can do this calculation using our calculator. A of 1.5 would be the same as v prime of 1.5, which turns out to be negative 2.049. Since a of 1.5 equals v prime of 1.5 is negative 2.049, and that is less than 0, the velocity of the particle is decreasing and not increasing at t equals 1.5. In part C of the question, we are given that the function y of t represents the position of the particle at time t, and that y of 0 is 3, and to use that information to find y of 2, that is the position of the particle at t equals 2. All right, so first let's define y of t to be the position function, which would be the indefinite integral of v of t dt. Right, we can find this by using u substitution. If we let u equal t squared and then du is equal to 2t dt, then y of t will equal the indefinite integral of t times sine of t squared dt, which is 1/2 the indefinite integral of sine of u du, and sine is one that we should know the antiderivative for. The antiderivative of sine is negative cosine. So we get negative 1/2 cosine t squared plus c. Now, we use the information that y of 0 is equal to 3. So we set t equal to 0, y of 0 equal to 3, and then we have the equation 3 equals negative 1/2 cosine 0 plus c. Cosine 0 is just 1. So 1/2, negative 1/2 times 1 is negative 1/2. 3 equals negative 1/2 plus c. Implies that c is equal to 7/2 or 3.5 if you prefer decimals. And what this does is once we have the value of c, we now have a specific function for the position of the particle at any given time. That function y of t is negative 1/2 cosine t squared plus 7/2. And now that we have that, we can find the position specifically at t equals 2. So y of 2, we just evaluate our position function y of t at 2, and we get negative 1/2 times the cosine of 4 plus 7/2. Again, it is calculator active, so if you want the decimal here, it's going to be 3.827. In part D, we are asked to find the total distance traveled between t equals 0 and t equals 2, and it's important to understand for the purposes of finding total distance, there's a good chance we're going to need to take the integral of an absolute value of a function or split the integral into two parts. Our v of t function will equal 0 whenever t is 0 or t is equal to the square root of pi. And now we can use that information. The total distance traveled is the definite integral from 0 to 2 of the absolute value of v of t dt, which is the definite integral from 0 to square root of pi of vt dt minus the integral from square root of pi to 2 of v of t dt. Again, it is a calculator active question, so we can use the calculator to determine both of those integrals. And if we do, we can find that the total distance traveled is 1.173.